All right, in this video, we're going to talk about exponential growth. All right, so exponential growth is in the function form y equals a times 1 plus r to the t power. A has to be greater than 0, r has to be greater than 0, and this is exponential growth. We're going to talk about exponential decay in a little bit. And the growth, how you know this is a growth, is that there is an addition sign in the parentheses. Now, y is the final amount of growth, whatever that might be. A is the initial starting amount. That's why a can't be 0. You have to have some type of initial amount to start this off. R is the rate of growth in decimal form. So if we have some type of fractional value, we have to convert it. T is the time. And then the growth factor we can see is 1 plus r. So that's the growth factor. So let's take a look at how this works here. So we have an attendance of a music festival, and it says the annual attendance is 150,000. The attendance, which is y, increases by 8% each year. So they want us to write a function of this. So the initial amount is 150. Well, the initial amount is a. The a value is the initial amount. The rate of growth is 8%, 0.08. So we plug that 0.08 into r. Now pay attention to the 8% and the 0.08. We do have to convert into decimal form for this. Okay, so that's 0.08. 1 plus 0.08 is 1.08 times the initial value and then raised to the t power. So that would be our final function for this. And then we can plug in values for t if we wanted to determine what the expected attendance could be over time. All right, now that's a growth example. And again, how do we know this is a growth example? Because there's a plus sign in the rate of growth, or the growth factor. For exponential decay, it looks very similar, except now there's a subtraction sign in the factor, and this is what we call decay, rate of decay. So we still have the same values. We have y, we have an initial amount, we have a rate of decay, and we have time. All right? So let's take a look at this, because I think this is important. Again, what is different between these two? One, the rate of decay, we're subtracting, and also r, in this case, the rate here has to be less than 1. If we go back to here, r has to be greater than 0. So r can be any number greater than 0, but in decay, it has to be less than 1 because it's getting smaller over time. Okay, so let's take a look here. How do we know if this is growth or decay? Well, we're given a data set here, and we talked about in a previous lesson how the x values will increase by some type of rate. So in this case, we're adding 1. The y values are going to get multiplied by some rate. And in this case, they're getting smaller by a third. So we're multiplying by a third. And we see the constant multiplier here of 1/3. So as x increases by 1, y is multiplied by 1/3. So what's happening is the initial value is getting smaller and smaller and smaller. All right, if we take a look at this table here, we see that the x values are increasing by 1, and the y values are being multiplied by 2. So this is the common multiplier is 2, so this would be exponential growth. So again, the multiplier here is going to tell you if it's growth or decay. If it's less than 1, it's decay. Okay, so now we have this general idea. So let's determine in a given function if it's growth or decay. If you were just given this in the textbook, could you interpret what this means? So based on our formula here, right, we have 1 plus r. That's our growth factor. And so since it's 1.07, if we subtract off that 0.7, that would be our rate. All right, and because we're adding, we're going to get a value greater than 1, which tells us it's a growth rate. So if the decimal value in parentheses is greater than 1, it's a growth. Now, if we look at the next example here, we see we're subtracting, and it's going to be decay. So if our value in the parentheses is less than 1, that's going to tell us that it's decay. Right? And then the R value, when we do that, tells us our percent. So we're decaying by 2% in the second example, and we're growing by 7% in the first. Okay. All right. They want us to write these things. So do you notice the exponent is t over 4? That can really be written as 1/4 t. So what they do is they distribute that 1/4 into the parentheses. So down here, the t over 4 becomes 1/4 times 0.96. Well, 0.96 to the 1/4 power is 0.99. And so because the decimal value is less than 1, it's a decay. Now down here, we have a t minus 3. So what we do in this case is we're going to write it as a quotient. So if you guys remember, if we have a negative power, it moves down. So that negative 3 power will actually move the 1.1 to the bottom. And so we end up with this function 0.75 times 1.1 t. And so because the value in the parentheses is greater than 1, it is growth. All right, now let's take a look at some real life problems here. All right, so compound interest, I love this formula because it's a way to help increase the amount of money that you make. So it's very similar to what we have. Instead of A, we have P, and that's called your principal, which is your initial amount. We still have the 1 plus R, which is your rate in decimal form. N is the number of times a year it's compounded, and we'll talk about that in a second. So this is going to be your formula we use for compound interest. So let's take a look here. You get $100 for your birthday. You put it into a savings account that earns 6% interest, which, by the way, this doesn't happen anymore, but just say it did. You get 6% interest compounded monthly. That means whatever money you earn on that 100 goes back into your account every month. Sometimes it's compounded monthly, annually, every couple months, every couple weeks. The more you compound, typically the faster your money will grow. Okay, so again, if you compound it just once a year, that's okay. Compounding it twice a year increases your amount of money.
Good morning, everybody. I'm a little bit late here, but welcome back to Mallow. You have the public come to the office after the bell rings. Grace Shooter, Jada Pantaleo, Spencer Scott, Sonia Peterson, Jan Suhair, Ashana Moradia, Chloe Szymanski, Lanaya Statler, Ivana Tabaka, and Stella Tabaka. Thank you, everybody. Have a great day.
Okay, so the initial value is $100. That goes in for P. Our rate is 6%, which we changed to 0.06. And it's over a time period of 1 year. The number of times it's compounded. We also take that N and make it 12 times T. So we would end up with this type of function, $100, our initial amount. And then once we combine this 1 plus and then the decimal value, we get 1.005 raised to the 12th t power. So you could plug in values for t in years and determine how much money that you would have after so many given years. Okay, so there's some different problems that we have, and hopefully that makes sense to you guys.